Hey guys! So today we are reviewing how to solve two-step equations. I know we did this a little bit before break, but I didn't feel like that everyone had it really mastered and was fully confident in it. So we're taking this day this week to go over it, and then next week we're going to do some different activities with it just to make sure that we are all completely mastering that standard before we move on. I do want to let you know that this is going to be my last video that I do because now we have that Zoom time during third period. For seventh grade, your third period is 10:16 to 10:59. So on Canvas, on a day that we are doing like a real lesson where you're not kind of like working independently, I will let you know on Canvas, like today, I would recommend coming into the Zoom. On days where it's more independent and I feel like you can do it on your own, like on our Friday work days, I'll have the Zoom open, but I won't say that it's recommended. It's just like if you need it, it's there. But that since now my time during those online periods that I had last semester, now I actually have students in here. I'm not going to have the time to make those videos every day like I did last semester. So, that being said, this is going to be my last video where I'm working one-on-one with the computer. What I will do is I will record our Zoom lesson and I will post that after the fact. And so you'll have that available. It just won't be as interactive. If you come into the Zoom, you'll be able to like ask questions and that kind of thing. So that's just more efficient for your learning, okay? But I know things come up. You might not be able to come to the Zoom that day. So I do want to still record the Zoom and I'll post those. It just won't be until it'll be probably later that day. Okay, so let's go over solving these two-step equations. The first thing we need to remember is our order of operations, which is PEMDAS. That is the order that we simplify expressions. So if we have a long expression of things, no variables, we're just kind of like simplifying that expression down to one number. That's when we use order of operations, right? However, when we are solving an equation for the value of a variable, we're actually undoing everything that has been done to that variable. So what we do is we solve it in reverse order. So we undo addition and subtraction first. We undo multiplication and division. Then we undo any exponents. And then we save those parentheses for the last thing, okay, to solve. Most of the ones in seventh grade, you're not going to see exponents in parentheses. It's just mainly going to be multiply, divide, add, subtract that have been done to x, okay? So in this first example, we have 4x minus 8 equals 16. We want to start on the side where the variable is. Let's see what has been done to x. 4 has been multiplied by x, and 8 has been subtracted from x. So if we're going in reverse order, we want to undo that subtraction first. What is the opposite of subtraction? It is addition. So what we want to do is add 8. And I'm trying to think what might be better with this. I'm going to see if I can zoom in on this a little bit more. Whoa, that's too much. Okay, that's a little bit better. Okay, so we're going to add 8 on both sides. Some teachers want you to draw this line down the equal sign. If that makes you feel better, do it. I like to put an equal sign just because on this side I'm doing plus 8 and that is equal to plus 8 on the other side. Do whatever makes you happy. Whatever works for you, I'm great with that. So we're going to add 8 on both sides. Then we kind of go down our list. We look across our equation and see what happened to each piece of the equation. 4x, we didn't do anything to that. We didn't mess with that part at all. So that just needs to be dropped down into our new equation. Then we're going to look at this piece. Minus 8 and plus 8 equals 0. 16 plus 8 equals 24. So now that we've performed all those operations to our equation, we now have kind of a new equation. It's more simplified. 4x equals 24. Then we're going to undo this multiplication of 4. The way we do that is we divide by 4. So 4x divided by 4 equals 1x. 24 divided by 4 equals 6. Okay, so that is the first example. Let me go back and trying to figure out how to get over here. There we go. Okay, the second example, we have division and subtraction. Again, we want to reverse the addition and subtraction first. So to reverse minus 5, we're going to add 5 on both sides. Okay, so we're going to add 5 on both sides. We're going to bring down y divided by 12 just because I didn't do anything to that. So that piece stays the same. This piece cancels out. This piece becomes 16. 11 plus 5 is 16. Our next step will be to reverse division, which would be multiplication of 12 on both sides. And our answer becomes 192. I promise I can't do math that fast. I just already knew the answer from yesterday. All right, now we're going to get down here into doing some decimals and negative numbers, which y'all see these sometimes and y'all just think, oh my gosh, my brain already hurts. I promise it will be okay. We're just going to kind of just treat them like, real numbers. Okay, so the first thing we're going to do, this is multiplication and this is addition. We want to reverse that addition. And this part didn't change, 3.2x. This cancels out. And here's where a lot of people get stuck is a negative minus a negative, a negative minus something. Think about a number line. When you add, you move to the right. You get bigger. When you subtract, you're moving to the left because you're getting smaller. Same thing when you're working with integers, okay? Think about a number line. Think about negative 23. So if I drew a number line, here's 0. Negative 23 is out here. If I am subtracting 2, let's just pretend it's just 2. If I'm subtracting 2, would I move to the left or to the right? Am I getting bigger if I'm subtracting, or am I getting smaller? I am getting smaller. So I'm landing here at negative 25, but then I also have that 0.6. So really I'm landing at negative 25, and 0.6 more is negative 25.6. So now I have 3.2 multiplied by x. I want to divide by 3.2 on both sides. So I get x equals, and the answer is negative 8. All right, last one. We have a negative number here, and I know it's added to this, but if we want to get rid of a negative, what we can do is we can add a positive. And they still cancel each other out just like subtraction and addition do. So we are going to add and we are going to need to multiply. So using our reverse order, we need to get rid of this negative number first. So we're going to add 6.85 on this side and add 6.85 on this side. So we end up getting m divided by 4 equals, and if I go back to that number line, I'm starting at negative 11, which would be about right here. And I'm adding 6, I'm going this way. So I'm landing at negative 4.15. Multiply by 4. And I'm going to teach you a little trick here. If you break this number apart, this negative 4.15, I know it looks ugly and scary and we don't like it, but let's just break it down. What is 4 times 4? It's 16. So then what is 4 times negative 4? It would be negative 16. But we're also doing 4 times 0.15. So our answer becomes negative 16, and 4 times 0.15 is 0.60. So I did that math without a calculator, just using strategies that I know, number facts that I know. I didn't have to write out a problem, okay? Always remember that. You can break down numbers, okay? Math works together in a way that it's always going to match up, all right? So anyway, m equals negative 16.60. What I would like you to do is to pick any 3 problems. So you have 3 more slides here. Actually, I take that back. Any 4 problems. We did one in class yesterday. We had time to do 1 problem. Everybody got to pick 1 problem to solve. But then today, they're going to solve 3 more. Okay? So I want you to pick a total of 4 problems. Any 4 from the rest of the problems here. If y'all have any questions at all, you can always inbox me. I am here. I hope y'all have a beautiful weekend. Love you guys. Bye.